Hi, this video will cover section 2.3, evaluating logarithmic expressions. And this video is for the class Math 0305 with the core requisite of Math 1324. So what the objective of this lesson is to get you more familiar with how to evaluate a logarithmic expression with your calculator. And so what we have in the calculator, what we've seen so far, are two types of logarithms, and that would be the one with that has the word log, and then in a different color, it might say 10 to the x. And this is probably if you have TI-84. And then you have another key that will say ln, natural log, and then you have something that requires the second function that will have e to the power x. So because those are the only two keys on your calculator, for us to be able to calculate some logarithm of base 11 or base 5, like the ones that we have here, so for those, we will have to convert them into base 10 or base e, which will be the natural log or the common log, which is base 10. Now, the change of base formula, it's written here, and that's what we're going to do on the second page. But before we get to that, we're going to evaluate some of these ones by hand. And so for this, we're going to be relying on that rule that states that if you are taking the log of a number and the base is the same as that number, what we call the argument, then the result will be whatever the exponent is for this argument. And so in this case, to generalize it, we will say it's just x. Now, if we didn't have an exponent, then we do understand that there is an implied 1. And so in that case, the answer will be 1. And so what we're going to be doing with these logarithmic expressions is try to rewrite, in this case, the argument is 125. So we're going to rewrite 125 so that is in base 5, just like the base of the logarithm. And so that will be 5 to the third power. And so with that, we notice the argument is 5, as same as the base. So even the prefix log will get canceled, and the answer will just be 3. Remember, this question could be read as, to what power do you need to raise 5 so that you get 125? And that power is 3, because 5 times 5 times 5 will give you 125. Now with the next one, we're going to do the same, try to rewrite 121. So to what power do you have to write 11 so that you get 121? And that will be 11 squared. So here we can cross this out, and the answer becomes 2, just like that. The very last one, we have 1 over 25. So that is telling me that we're going to have some negative exponents because we have a fraction. So in this case, 125 will be 5 to the third power. However, we want to move that 5 to the third power to the numerator. So in this case, it will be 5 to the power negative 3. Remember, the exponent goes from positive to negative. And if we cross this out, the answer will be negative 3. And that's it for those logarithmic expressions. Now, over here, what we're going to do, same idea, we're going to rewrite 81. And so, in fact, that 80, not the 81, I'm sorry, but the number 3, we could say, to what power do you have to raise 81 so that you get a 3? And so in this case, we could do the following. In fact, I'm going to, okay, no, I do have an idea. Okay. So if we calculate the square root of 81, that is equal to 9. And then the square root of 9 is equal to 3. So the fact that I am taking the square root of 81 twice, I could actually say, we could do this. and then take the square root again, and that will give us the same 3. So just to prove to you, if I take the square root of the inside first, it will give me 9, and then I take the other square root, and that will give me 3. So that expression is equivalent as me saying 81 to the power 1/2, and then the other square root to the another 1/2. So now there's a rule with exponents that if we have the power of power, we can multiply those two. And so what we will get is 81 to the power 1/4. Now, if I convert this back into a root, it will be the 4th root of 81. And so to what power do I need to raise 81 so that I get 3? And that will be to the power 1/4. If you put that on the calculator, you will see that you will get 3. And the answer will be 4, 1/4. So if you raise 81 to the power 1/4, or you take the 4th root of 81, the answer is 3. Now let's move on to the next two problems on this side. So here what I'm going to do is use the power rule in reverse. And so the coefficient becomes the exponent of the argument. So this will become log base 6 of 1/36 to the power -4. Now, in fact, I don't want to do that. So I'm going to actually take it back because there's actually an easier way for us to solve this. And in fact, we're just going to leave that there, that -4. But what I want to do instead is I'm going to rewrite this argument so that I put there 6 square. And then let's put this -4 over here where it was. It's still the coefficient. And so from here, what I'm going to do is take that 6 square and bring it to the top of the fraction. So it will be 6 to the power -2. Now from here, we could have these two expressions are multiplying each other. So here the base matches the argument, so the answer will be -2. But we still have this -4 in front of it multiplying it. So -4 times -2. And the answer for this will be +8. Now the next problem, we have 12, and then we have a common log. Remember, common log, if you don't see the base, is a base 10. And you have 1,000, so we can rewrite 1,000 with 10 to the power 3. So if we cross this out, we will get 12 plus, the answer here is 3. So 12 plus 3 is equal to 15, and that is the answer to that expression. Now, on the next page, we are required to do these problems on the calculator. And so, of course, the way that you will enter it is pretty easy. On the first one, you will need to use your key that has log. And then, of course, you will enter your number. Some calculators open parentheses automatically so that you can enter the argument. Now, for this one, you, of course, need the calculator button that says ln. And from here, you don't need to enter a base. You will just enter natural log of 21. For the next one, you do have a log that is of base 81. So the way that you would change the base is by taking the log of the big number, in this case 3, the argument, and then divide it by the log of 81. Now here, remember, if we don't write a base, it is an implied 10. So it's not really necessary, but what is necessary is that you enter it this way. So you will press the key log, and then 3, and then division, and then you must press the key log again, and then you will enter 81. So don't think that you can just go like this and cancel the prefix log. That is not the case. Now, just like you can convert this to a base 10, you could also convert it to a natural log. So it will be the ratio of the natural log of 3 divided by the natural log of 81. And you will get the exact same thing. So this one, you will still need to enter it on the calculator as ln of 3 and then divided by ln of 81. And then you will press enter. For the next problems, we're going to do the same, change the base. So in this case, we will have -4. And then we need, actually, I'm going to go ahead and change the base of this one. So it's going to be the log of 1/36 divided by the log of 6. So that is the base. I'm changing it to a base 10. Because remember, your calculator can only find base 10 or base e. So now for this one here, it will be the log of the argument 2 divided by the log of 8. And of course, you have to press enter to get a decimal approximation. If you need to enter answers like this on MyMathLab, make sure you do read like how they want you to round. Now, if you don't want to use the key for log, you could use the key for natural log. So natural log of 2 divided by natural log of 8. And I repeat, on your calculator, you must press ln twice. Natural log of 2 divided by natural log of 8. So what I'm trying to say is that it's not equivalent to this. If you enter it that way, it will be completely wrong. That is not change your base. So now for the next problem, I'm going to just change it to natural log. So natural log of 314 divided by natural log of 11. And in fact, that is the exact answer. If you need a decimal approximation, then you will have to enter that on the calculator. So here, this will be the natural log of 23 divided by the natural log of 4. I will probably keep them in parentheses since I have to add that 6. So the here will be 5 minus parentheses natural log of 15. Here I'm not changing the base because natural log is a log I can get on the calculator. So here this is natural log. Make sure you keep your 5 divided by 6 together. In this case, you are taking the natural log of a fraction. And then close parentheses and enter -8 or -8. So here, when you do the same kind of problems here, it looks like changing the base, so you already know what to do. You enter natural log of 8, division symbol, and then natural log of 5. Same thing applies for this one. So in this case, I will use parentheses just to make sure. Okay, not this one, 390, and then divide it. And then again, natural log of 12, close parentheses, and then -3. The last expression, we will enter natural log. And now here, we do not need to put natural log twice like we did on the previous one. Here we had natural log twice. Here we only have it one time. But what needs to be in parentheses is the argument that we have here, like that. And then after that, divided by 0.035. So practice entering that on your calculator, and good luck with the homework. So thank you for watching.